Okay, I'm going to do each problem separately. You're going to notice that you see how I have this as number one. They all have a number sign written in the top left corner, and they're not posted in order on Classroom. I tried twice, I failed twice, and so they're not in order, so just deal with it. Okay, so here we go. The thing that you need to know, the biggest thing you need to know about integral as net change is that if we take an integral of a rate, the result will tell us how much. This is the big concept that I'm going to keep going back to. So for example, if I took the integral from 0 to 3 of something that was in miles per hour, in the end, I would get how many miles, or I'd get the number of miles traveled from time equals 0 to 3. So that's what the integral is telling me. It's an accumulation function. It's telling me how much change there was. So again, if I have any function that's a rate, miles per hour, meters per second, whatever, and I integrate it, it'll tell me how much change I had. So all of these problems are going to have some aspect of that, plus some other stuff that we've talked about, whether it's average value or maybe even having to talk about maxes and mins and stuff like that. So here we go. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. So all of a sudden, I know water is pumped into the tank at a rate of 8 gallons per minute. So I know if I integrated 8, I would get how many gallons from one time to another. Water leaks out of the tank at a rate of t plus 1 gallons per minute for t between 0 and 120 minutes. At time equals 0, the tank contains 30 gallons of water. So the other important thing is how many gallons of water is there to start with. That's going to come up. Sometimes our initial value is 0, but sometimes our initial value is a number that's not 0, and that's going to have to be taken into account. Okay, so let's see. Okay, part A. How many gallons of water leak out of the tank from time equals 0 to time equals 3 minutes? So I'm going to go and see, well, how fast is the water leaking out? The water is leaking out at a rate of t plus 1 gallons per minute. So to find out how many gallons went out, I'm going to integrate the square root of t plus 1 from 0 minutes to 3 minutes with respect to time. This is this is a no calculator question, so they actually do want us to go do this. So I'm going to leave the math of this to you, that means you're probably not going to do it, but you should go through and integrate that, and you should get 14/3 gallons. Okay, make sure you put a label on there. Sometimes it says indicate units of measure, and then they're going to give you a point for it, but still make sure you put the gallons on there or whatever. Okay, part B. How many gallons of water are in the tank at time t equals 3 minutes? So now I want to know not just how much went out, but how much is in it. So I'm always going to, when I want to know how much is in the tank at any given time, I need to consider how much I start with, take away how much goes out, add in how much goes in, or vice versa, whatever. I think actually I usually do it in the other order, but whatever. So how much do I start with? I start with my 30 gallons. I'm going to actually go in the other order. I just like to do it better. I'm going to add in how much went in, and I'm going to take out how much went out. So how much goes in? Well, they said we're going in at a rate of 8 gallons per minute. So I can either do the integral of 8 from 0 to 3 with respect to time, or I can just go 30 plus, this is 8 gallons per minute for 3 hours. Either way, I'm going to get the same answer. Go ahead and figure that out. If I integrated 8, I'd get 8t. Then I'd plug in 3, plug in 0, and subtract. I'd get the same thing as I'm going to get here. So you can do this part with integration, or you can just figure it out. And now I need to take out how much came out. I don't have to write the integral because I did it in the last problem. I know that this is going to be the integral from 0 to 3 of the rate that we're coming out. which I know from the last problem was 14/3. Okay, so starting amount plus how much goes in minus how much goes out. And in the end, you should get 49 1/3 gallon. Okay, write an expression, part C, for A of T, the total number of gallons of water in the tank at any time T. So now they want a more general expression. So for part C, the amount of water in the tank at any time is going to equal how much I started with plus how much goes in. So I can either write this part as 8 times T, or if you just want to stay in your zone and like keep using integrals the whole time, then I can say the integral of 8 from 0 to T, because I'm giving a general expression for the amount of water in the tank at any time T, minus the integral of the square root of T plus 1 from 0 to T with respect to T. So that's what they're looking for part C. Part D, now we get a little bit more complicated. At what time between 0 and 120 is the amount of water in the tank a maximum? Okay, so I try to stay in my lane and think about what it means to be a maximum. A maximum means the derivative changes from positive to negative. So if I just came up with an expression for the amount of water in the tank, I want to find out for part D when does A prime of T change from positive to negative? That's what I'm looking for. If I want to know when is there a max for the amount of water in the tank, I want to know when does the amount of water have a maximum. So when does the derivative of the amount of water change from positive to negative? Now we have a kind of a Leibniz law situation going on. I need to find out what is A prime of T. So A prime of T, the derivative of this, so the derivative of 30 is 0. The derivative of 8, the derivative of the integral of this is 0, right? Because I could have had that as 8. No, it's just 8. Oh, that's weird. Okay, never really thought about that actually. So to do Leibniz law with this, I'm replacing T with whatever variables here, but there is no variable. So it's just 8 minus, and the derivative of this, plug in T for this variable. Technically, I should probably have this as an X with a dx, but it doesn't really matter. So plug in the T. And I want to know when does this equal 0 and change from positive to negative. So I'm going to solve this. Square root of T plus 1 is going to equal 8. Square both sides. T is going to equal 64 minus 163. Oh, wait, whoops, hold on. Oh, no, that is right. I was thinking, did I have two answers? It's hard to think and use this pen at the same time. 64, 63. So let's see, at 63, look at A prime. Let's plug in a number bigger and a number smaller. So plug in a number bigger than 63, and this was the derivative over here. Plug in a number bigger than 63, like 64. Let's plug in, I'm going to plug in 99, because that'll give me a perfect square over here. I get a negative number. Plug in something less than 63, like 24, and that's going to give me a positive. So yes, the derivative of A changes from positive to negative when T is 63. So what did the question say? At what time is the amount of water a maximum? At time equals 63, and did it say justify? Yep. So because A prime of T changes from positive to negative, just like I set up here. Sweet. All right, I'm going to go on to the next one in the next video.